So, if you spent any time online recently, you've seen them. I mean, how could you miss them? These super advanced robots pulling off backflips, doing these perfectly synced dances. It's like something out of a movie. It is absolutely incredible to watch. But you have to wonder what happens when the camera stops rolling.
You know exactly the videos I'm talking about, right? The ones from Boston Dynamics and other companies where these robots are just grooving. Honestly, they have better moves than most of us. They're parkouring over stuff, they're just blowing our minds. And they go viral for a really good reason. They're amazing, a little bit weird, and they give us this fascinating peek into what's next.
But that brings up a huge question. Okay, the dance party's over, the weekend is done. What are these machines actually for? Are they just incredibly fancy showpieces, or do they actually clock in for a real job? And you know what? A lot of people are asking that exact question. There's a totally healthy dose of skepticism out there. I love this comment from a user on Reddit, basically calling it an expensive, big toy. And that's a fair point, but the reality is starting to look a whole lot different. Because yeah, beyond all that viral hype, there's a new kind of workforce that's literally clocking in. These robots are stepping off the dance floor and onto the factory floor, the construction site, and into some of our most critical infrastructure. So these working robots pretty much come in two main flavors. On one side, you've got your humanoids, the bipedal, two-legged robots. They're designed to work in spaces that were built for people using tools made for our hands, kind of like the bots you see on Neo's car assembly line. And on the other side, you've got the quadrupeds, the four-legged bots, which are all about stability and getting around on any kind of terrain. And for the humanoids, this is a big moment. We've officially entered a new phase, what some folks in the industry are calling humanoid version 0.5. Now, what that really means is that these robots are now capable of doing precise, autonomous manufacturing work. We're talking inspecting car parts or installing tricky wiring, all by themselves.
And on the four-legged side of things, well, you've got the biggest celebrity in the robot world, Boston Dynamics Spot. But Spot is so much more than a viral video star. It's a serious industrial-strength tool. Its job is inspection and data capture in places like construction sites or energy facilities, places that are often difficult or even dangerous for people to go.
And as you'd expect, it comes with a pretty professional price tag. A starter Spot will set you back about $74,500. This is a serious investment for large companies. But that's not the whole story.
See, this isn't just a game for giant corporations anymore. Meet the Unitree Go-To. It's part of this new wave of what are called prosumer robots. That's professional-grade tech that's actually accessible to consumers. It's packing some serious hardware, like 4D LiDAR for seeing the world around it, but it's aimed at a much, much wider audience.
How much wider, you ask? Well, the starting price for a Go-To is just $1,600. Think about that. And this just perfectly shows how fast this technology is spreading. The gap between that super high-end industrial tool and a really capable, affordable alternative, it's closing, and it's closing fast.
Okay, so we know what they are, but what are they actually doing all day? Let's take a quick trip around the world to see what a robot's resume looks like right now.
This quote from an engineer at National Grid really says it all. These machines aren't just replacing a tool. They are being integrated directly into human teams to make things safer and more efficient for everyone.
And the jobs they're doing are incredibly diverse. I mean, look at this. In the Swiss Alps, they're inspecting dams for tiny cracks. In Zurich, they're patrolling massive data centers. Over in China, they're right there on the auto assembly line. And all over the globe, they're creating these amazing 3D maps of construction sites to track progress. So why are they getting these jobs? Well, this quote from a research paper on dam inspections really gets to the heart of it. A lot of these tasks, when humans do them, are slow, they're really difficult, and frankly, the results can be inconsistent. Robots offer a solution that is objective, tireless, and, a lot of the time, way safe.
But how do they do it? How does a robot navigate a cramped tunnel inside a dam or work side by side with a person on a factory line? It's not just about having strong motors. It's all about the incredible tech that acts as their brain.
So, a huge concept here is something called human-robot collaboration, or HRC. And this isn't about replacing people. It's about creating shared workspaces where robots can help out their human coworkers by literally understanding what they're doing, reading things like hand gestures and body posture to figure out what their human partner is going to do next.
So how does a robot actually see the world to make that collaboration happen? We can break it down into three pretty simple steps. First, it scans its surroundings using sensors like LiDAR, which is kind of like radar but with light, building a 3D map, and cameras. Second, its AI brain crunches all that data. And finally, based on that analysis, it predicts what to do, and then it acts.
And the power of that AI analysis is just astounding. In that study of the dam inspections in Switzerland, the AI models were able to spot structural cracks with up to 97% accuracy. I mean, that is a level of precision that's incredibly hard for even a trained human to achieve consistently.
So this all brings us to the bigger picture, right? This new robot workforce isn't just changing technology. It's creating brand new economic and even geopolitical landscapes.
Get this. Right now, a single country, China, controls an estimated 63% of the entire global supply chain for humanoid robots. That is a massive, dominant position in a market that is just set to explode.
But when you look at the research, the brains that power these machines, it's a different story. The United States is actually leading the pack in research on human-robot collaboration. But you've got Japan, China, Germany, and the UK all competing intensely. So the race isn't just to build the robots, it's a race to innovate.
So we come full circle, back to the price. That $74,000 price tag for the high-end industrial robots is a serious chunk of change, which, up until now, has kept them mostly in the hands of big corporations.
But that $1,600 robot, that changes everything. It just blows the doors wide open for small businesses, for researchers, for developers all over the world to start building and innovating on these platforms. It's basically democratizing the future of robotics. Which leaves us with one final big question. The robots are here. They're not just on the internet anymore, they're in our workplaces. And they're getting smarter, more capable, and cheaper every single year. The technology is clearly ready. The real question is, are we ready for our new colleagues?